Okay, I think you can probably tell I'm a big fan of repetition. I think it smooths those neuronal pathways. All right, so sketch. Now, this is what I see. See a V-shaped down. I see 4 is the critical number for this absolute value. That makes the absolute value 0. And max in this case is going to be multiplied by negative. So 4 gets a 7. Y-intercept is to the left. And if I put in a 0, 12, negative 24 plus 7, negative positive 17. No, negative 17. No, let's just check this real quick to see if we have a slope of 6. Plus and minus 6, I should say. So let's see. Negative 17 to 7, I'm going up 24 divided by 4. Yeah. All right, so we're good. Piecewise, get Alfred Hitchcock up on the board. Oh, it's G of X. Got to be exact here. G of X is, let's use 6. So I'm going up on the left and down on the right. Increasing, decreasing. All right, so I'm increasing. There's Alfred increasing 6. I'll use the vertex 4, 7. Of course, I can only use that piece for x's that are on that side of 4. And I'm decreasing on the other side of 4. Yeah, so now we want to set these pieces to negative 29. And why don't I take a shortcut here? Don't have to write so much. So we're subtracting 7 minus 36, dividing by 6, negative 6, adding 4, negative 2, I believe, unless I made a careless error. Let's go here and set it to negative 29. Negative 36, divided by negative 6 is positive 6. Adding 4 is 10. Let's do a quick 10 minus 2 divided by 2. 8 divided by 2 is 4, which is the critical number. So we're going to assume that that's correct. We have V-shaped down, and we're looking at critical numbers at 10 and negative 2. And we get sign changes there. And we want to be bigger than negative 29, which is going to be above this axis. And so that is, all those y values are like this 7. And that 7 is bigger than negative 29. And all of these y's will be as well. So that's true. So I would just simply say x less than 10 and greater than negative 2. Nice, easy way to communicate that. All right, so going a little faster each time we do one of these exercises, because the problem should become more and more familiar. And our goal is to put this in long-term memory, which is why we're getting our reps in. All right, I make a number line. See my numbers. 8's a problem. A consideration. Certainly 3 also. And actually the number 4 in this case is critical. All right, so can I put numbers bigger than 8 in? 9, 10, 11. No, that gets me square roots of negatives now. So no, I can't use those. Can I use the number 8? Yeah, I can use it here and I can use it there. So yes, 8 works. Can I use the number 5, something in between? Ln 2, we know that. Roughly 0.7, 8 minus 5 is 3. We know the square root of 3. All of you are saying 1.73 right now as an approximation. So yeah, we can use it. So yes, we can use it. Can I use the number 4? 4 minus 3 is 1. The Ln of 1 is 0. Can I divide by 0? Heck no. Can I use numbers between 3 and 4, like the number 2? Oh, that's not between. 3.5 is what I'm going to say. 8 minus 3.5, positive square root, no problem. 3.5 minus 3, 1/2. Oh, and you're all shouting right now. Ln of 1/2 is approximately negative 0.7. So no problem there. So 3 works. 3, numbers between 3 and 4 work. Does the number 3 work? No. You cannot find something on top of E that will produce the number 0. Now, you would think by this time, the number of times I've done these videos, I would have an eraser with me, but I don't. All right, I do now, and forgive the break in the action. Okay, so what do we have here? The answer to this one, I guess I'm going to put it way up here, is 3 did not work. So 3 to 4 and 4 did not work. So union 4 to 8 And 8 did work. I believe I've got that captured. Interval notation. All right, so now we're gonna use another, we're gonna graph this. So at 0, we have ourselves a, don't know why I did that. At 0, we have a cubic root, and it's changing signs there. Same thing happening at -2 because it's to an odd exponent. We'll call that -2, we'll call that 0. And at 3, we have no sign change. But we've got a negative multiplier here, which means that all of this exponential activity eventually going to be heading to negative infinity when I go to infinity. You know, I've got at 0, I've got a cubic root, so it's something like that, linear. So that's the basic shape. And if I'm looking at greater than or equal to, well, that's pretty easy, -2 to 0, and also equal to, so bracket, union 3. That's what I'm seeing. And you write to me if I make any mistakes here, because I'm not going to double check. Just getting some practice in. And what happens when I write an answer key to a test? I do the same thing. I go through these, usually mental math. It's good practice for me, especially in my advanced age when I'm getting forgetful. All right, we're going to use the same technique here. Can I use -3? Absolutely not. I'm not allowed to divide by 0. Can I use the number 4? Absolutely can, because I know 0 divided by 7 is 0. All right, now what am I less than or equal to? Well, I can see if I put a million in the numerator and denominator. I'm not less than 0. No. And I'm going to get a sign change here, because this is a linear function that changes signs at 4. This is a linear function that changes signs at -3. So I'm going to get a sign change. So this is going to be yes, and this is going to be no. And I said I can use the number 4. So it looks like I'm going to put my answer up top. No, it's easier to write it here. X's are greater than -3, right? But less than 4 or equal to 4. Less than or equal to 4. Okay, so that's a good way to communicate to the reader. All right, now we're going to sketch 2x minus 8 over x plus 3, and we're going to look for, yes, between -3 and 4, our graph's going to be below the x-axis. Bigger than 4, it's going to be above. Less than -3, it's going to be above. So let's go after it. -3, asymptotic behavior. End behavior, 2 to 1. Y equals a 2 to 1 ratio. When I start putting huge numbers in. Over here, numerator to denominator, 2 to 1 ratio. Very close. I should put approximate. Well, I guess the dotted line suggests that. All right. Y-intercept, -8/3. We'll call that -8/3. For the y-intercept, x-intercept, +4. Just a little bit bigger to the right, +4. Can clearly see now what's going on here. And no more x-intercepts, so it's got to look like that. So there's our sketch. And there's our negative numbers. Where are they? Between -3 and 4. Hopefully you're being able to see that a little more clearly each time we do these. What's g of x? This is the graph of g of x. What is the limit as x goes to infinity? Well, the bigger the number, the closer I get to 2. So that answers it 2. Can you see that? Yep. What about going to -3? Well, in a table, I can go to -3 from numbers bigger than 3 on the right, numbers less than -3 on the left. And it looks like I'm headed to positive infinity here, to negative infinity here. That's not the same. Those are not the same y values. So this limit does not exist. Now, what if I put a plus sign there? Well, that would mean I'd go from 4 to 3 to 2 to 1 to 0 to -1 to -2 to -2.999999999. And it looks like I'm headed to negative infinity. And if I came in from the other direction, -10, -9, -8, -7, -3.01, I'm heading to positive. So we want to get you familiar with those concepts, because we don't want you to bomb calculus if you get there. All right, so what's the range? Well, x squared is this graph. And that graph takes me from 0 all the way to infinity, which means that this is an angle. The radius lengths, 0 to infinity. I just keep going around and around the circle, around and around and around and around and around. And I go up to cosine, so I go from 1 to -1, from 1 to -1, 1 to -1, 1 to -1. And then I do a little multiplication and a little addition. So the range, 8 in the middle, up 20, down 20. The range is -12 to 28. And this graph at 0 would actually start at the max, and it would probably start to accelerate. Because, you put a number like 10, well, 10 squared is 100. 11 squared is 121. 21 radius lengths is 6.28 once around. So you've gone around the circle 3 times. You're only changing by one value, one x value from 10 to 11, but you're getting close to three revolutions. Worth thinking about, especially if you want to understand the chain rule when you get the calculus, if you get the calculus. All right, so I should be able to look at these. Well, I guess I duplicated this. I forgot I put it on the board. So you want to be able to look at these and say the center by May 15th, you want to be able to go -4, 3. And you want to figure out radius of 10 just by looking at it. All right, now, where did I get those answers from? Completing the square was -16, and that's what Pythagorean theorem is, right? One area, another area, adding up to the third. So we're creating the x and y sides of the triangle. And so the y side is y -3 squared minus 9 equals 75. We put that over there. We get x plus 4 squared plus y -3 squared, moving the constants to the other side. If I did this properly, then I can see that 100 is actually 10 squared. And so I have x plus 4 is one side of the triangle, right triangle, y -3 is the other, and a radius of 10. So if this area, if the altitude side gets smaller, then the base square area's got to get larger. And so that interplay gives us the rotation, right? So that was correct. All right, sketch the bounded area for. Well, it's something you got to be able to do at another level of mathematics. And you can't answer what the bounded area is. You'll find techniques to do that aren't all that hard. But if you can't draw it, can't take that level of math. So y equals x minus x squared plus 20 is the same thing as -1 times x minus 0 squared plus 20. Hope you can see 0, 20. Right? And it's a cup shape down. And we want to get this area. And we better find their points of intersection. It's an Algebra 1 question. How do we find those points of intersection? We set x equal to minus x squared plus 20. And so therefore, x squared plus x minus 20 equals 0. I like to keep the coefficient positive. So that gets us x, plus 5 times x minus 4 equals 0. So therefore, we have positive 4, 4, since it's on the line, y equals x, and -5, -5. Okay, now what is that area? If I was going to approximate it, well, let's just approximate using a rectangle. Okay, and then there's error, this error here, which actually we could find exactly. So I'm going from -5 to 4, so that's 9 units as a base. And I'm going all the way up from -5 to positive 20, so that's 25 times 9, which is 9/4 is $2.25. So this big area is 225. And I could find the triangle and take it away, and I could estimate and take it away. And then I could get a little bit of a feeling for, bounded area. There's a lot better ways to do it than that, but I got a feeling that's where somebody started thinking about this. Kind of sure about that, actually. All right. But who really knows? Come on, science cart, behave. There we go. What do we got here for a question? Average rate of change. So y equals 1 over x. And I'm looking at 1/6 to 1/2, so I'm looking at the first quadrant. And I'm looking in this vicinity. So if I follow my finger, I'm going down pretty fast here. I'm looking for a pretty negative rate of change. It's easy to find out how you get from one place to another. Like, how do you get from 1/6 to 1/2, which happens to be 3/6? How do you get from 1/6 to 3/6? Oh, you said go up 2/6. Oh, so my x's are changing by 1/3. Okay. And if I divide 1 by 1/6, I actually get 6. And how do I, if I divide 1 by 1/2, I actually get 2. And how do I get from 6 to 2? I think I get down 4. So what's my average rate of change? -12. Yeah. Now we're doing a little fractional work. How do you reduce fractions? Take out the common factors. Well, I can see this is even. So that's 2x squared minus what? 98? No, they're still even, so I can take another 2 out. That's x squared minus 49. Oh, it looks like I can rewrite this as x minus 7 times x plus 3. That's the numerator factored. And now I can take the 4 out. If I take the 4 out, I get x squared minus 49, which happens to be x plus 7 times x minus 7. Oh, I can see that I really don't have to multiply and divide by x minus 7. So I can take those away. Then it looks like I've got my answer, x plus 3 over 4 times x plus 7. You can leave it like that in my class. You knew what to do and you did it. All right, let's go bingo, bango, bongo. Bingo, bango, bongo. So I got 5a times 3, 15a minus 9, minus 8a minus 28. Well, it's a good thing I put that parentheses, or I might have made a mistake with this subtraction. 12. All right, I'm going to use the old eraser here. 15a minus 8a is 7a. I'll put it there, and then I'll erase 7a. And minus 9 plus 28 is minus 19. Minus 9 plus 28 is positive. Excuse me. So 7a plus 19. Okay, and there's there an easy way to check this? Yeah, I'm going to throw a 2 in here. 14 and 9. Do I want to do this? 14 and 19. 28, 14, 24, 33 twelfths. 33 twelfths, I can take a 3 out, which gives me 11 fourths. Let's put a 2 in just this one time. We'll put a 2 in here. See what my answer comes out to be. Let's pretend I got a lot of time on the final. Got a lot of extra time. All right, I'm trying to get 11 fourths. So let's just do the math. 7 fourths minus 4 minus 7 is minus 3 over 3, which is minus 1. And minus a minus 1 is plus 1, and that's 4 fourths, which is 11 fourths. So looks like our answer was just fine. All right, by May 15th, you want to be able to look at a problem like this and go, oh, double, that's the element 2, 0.03. And so that's equal to 0.7 divided by 0.03, which is equal to 70 divided by 3, which is what? 23 1/3 years? 23 1/3 years. That's how long it would take to double your money at 3%. Well, let's show you why we can get there. All right, so the amount of money you get in your savings account when it's being compounded continuously requires an initial deposit. Let's say $100. Then the amount we're looking for is, I want it to double, right? Not triple, so 200. All right, so we're going to solve the equation 200 equals 100 E to the 3% is 0.03 t. Divide by 100, there's your 2. E to the 0.03 t. E means we put it in logarithmic form. Ln of 2 equals 0.03 t. And there's your ln of 2 over 0.03. And we already did that a little while ago. All right. Yeah, you're going to want to be able to do all three of these in 30 seconds or less by May 15th. You want to do them in your head. So I'll do them in my head just for practice. I like practice. So I think this one is going to be root 3 over 2. I think this one's going to be minus 30s, minus a half. I think this one's going to be undefined. Let's find out if I'm right. And if I'm wrong, it doesn't bother me because I got some practice in, and I'll correct my errors. All right, 35 pi over 6, I think is pretty close to 36 pi over 6, which is 6 pi, and that's on the even side. I'm trying to go 35, so 35, I'm going this way, right? So 35 pi over 6 is a 30-degree reference angle, and that is root 3 over 2, the longer side. And so, yeah, minus 29 pi over 6. I got to make a new circle. Get a chance to practice my rotator cuff problems. But they're not too bad, not too bad, but that one was pretty bad. Minus 29 pi over 6 is pretty close to minus 30 pi over 6. And this is minus 5 pi. The odd are on this side. Minus 29 is one less. So that's it. And it looks to me like I've got minus a half. Okay, that's pretty good. 5 pi over 2 is the top of the circle right there. And I know tangent is all about sine divided by cosine, height divided by width, and 1 divided by 0 is undefined. So there's a little practice there. Okay. 3x plus 18 is a negative 6 is the critical number. That gives me the square root of 0. And it's going to the right. Y equals x, I can put in the next y-axis now. All right. The square root of 18 is a little bit bigger than 4. So let's just call it 4.5-ish. Right? Y equals x. Ooh, that tells me that I've got an answer that appears to be bigger than 4. So I got to find this x, but I know there's only one answer. So let's go find it. One answer, and I'm going to guess it's around 5-ish. I don't know. Let's go find it. No, 4, 5, maybe more than that. Let's go find it. All right, so we square both sides. So there's 3x plus 18 equals x squared. So 0 equals x squared minus 3x plus 18. So therefore 0 is equal to x minus 6 times x plus 3. X minus 3, excuse me. Positive 18 should have been negative 18, excuse me. Careless error there, corrected. And so now we want a negative, so x plus 3. Okay, well that fits. X equals 6 is our only answer based on the picture we had a second ago. We can check it. 3 times 6, 18 and 18, 36. The square root of 36 is 6. Negative 3 is going to give us a fictitious answer. The square root of 9 is 3, but x negative 3, a little bit of a mirror image, but not true. So just the one answer. So you want to be able to look at these and hopefully write x squared minus 4x, 4 minus 7 minus 3, I think. No. Maybe. Let's see. I feel like my brain was a little sluggish there. So we got x minus 2 equals plus minus the square root of 7. We're going to square x squared minus 4x minus plus 4, excuse me, equals 7. Take 7 away. Yeah, it was that. X squared minus 4x minus 3 is what makes it wrong. All right, so now where are we? We're at, I'm giving you one root of a cubic, and we're going to find the other roots, and then we're going to graph the cubic. We're going to sketch this with all the information that we get. So if x minus 4 is a root, then x plus 4 is a factor. And really what I'm doing is finding out what times what gives us this. I need x squared, there's 4x squared, I got to get to minus 3, so I got to minus 7x squared takes me to that. 4 times minus 7 is minus 28. I gotta get to minus 18, so I gotta go up 10. 10x, yep, that works. And 4 times 10 is 40. So there's my other depressed polynomial. That's what you call it or not. But this is x plus 4 times x minus 5 times x minus 2. That equals 0. So those are your other roots. So since we've got those roots, let's take advantage of it. Let's keep it kind of small. Let's go negative 4 here. Let's go negative 2 here. A positive 2, excuse me. Just butchered that. Negative 4, positive 5, and positive 2. How about we make this our origin right there? Let's put positive 2 here. And let's positive 5 maybe there. All right, that's not the greatest. Let's move this one over. All right, I don't know if this is going to help or not. But what's the most important thing after the roots? Point of inflection. Actually, it's more important than the roots. Point of inflection, do you remember how to get it? Minus b over 3a. Now, I probably should have said this at the beginning, but I'm hoping you're pausing the video, trying all these problems yourself, and then just checking to see if you're correct. So that gives us 3 divided by 3 is 1. Oh, that's nice. So we got a 1, and we put a 1 in really quickly and easily. So I got minus 21 from 41. Is that right? Let's just do it out. 1 minus 3 minus 2 minus 20 plus 40 is positive 2. All right. So 20 would be about up here, and 1 would be just a little to the right. So right there at 1 comma 20, we're actually coming down fastest. Right, because this thing has got to go up through here, through here. Okay, and all right, so that's all I've got so far. I know that 0 gets me 40, so 0 is a little to the right, that's here. So 0 gets me 40. And I know I'm going down at 18 to 1 there. I know that's happening. So how fast am I going down here? C minus 3a h squared, h is 1, a is 1, c is minus 18 minus 3, minus 18 minus 3. I'm actually going down at 21 to 1 right there, 18 to 1 there. So I'm gonna, and that's 3 units of change in 20. So it's gonna look something like this. It looks something like, oh boy, did I miss this. Woo! I needed to be further apart. Let's just do this. Okay. Now, if I want these x values, which I should get, then it's really h plus and minus the square root of minus over 3a. H was 1, plus and minus, we now know that's 21, because that's m, the slope at the point of inflection, divided by 3. So I have 1 plus or minus the square root of 7. As x values here. This one is 1 minus the square root of 7, which is a little more than 2 units. So, you know, we're near negative. We're near negative 1 here, and over here would be near 3, I guess, a little more than 3. So 1 plus 1 7, and I have to plug that into a calculator probably. I don't know the graphing form for this would then y equals. I'll put the 1 here. X minus 1 cubed minus 21. X minus 1 plus 20. All right. And would it have been hard to plug in 1 plus or minus the square root of 7? Square root of 7 cubed. Yeah, it's not that friendly. So we'll leave it there. All right, 1 period for cosine and sine curve. Come on, science curve. Oops, I'll hit this. Working well, need to hear this. All right, so 1 period cosine. Cosine is 0. 0 is walking around the circumference of the circle. Oh, at 1, excuse me. The cos, well, that's what's going to make it 0. So 1 is a max. Right? So if you don't walk around, no walking around the circumference, you have a maximum width of 1. So I'm going to use that because I can go max to max for 1 period, and I know that a 1 is going to act like a 0, no walking around the circle. And that's gonna get me, let's see, there's 20, there's 23, and there's 17. And I know my multiplier is 5. And if I divide 2 pi by the multiplier, I actually get the period. So this is 1 plus 2 pi over 5. Right, and that's gonna bring me back to 23. And that's gonna give me all kinds of symmetric places, right? So halfway is gonna be 2 pi over 10, or pi over 5, so on and so forth. But let's check this. This is probably the stumbling block. I don't think the range is. So let's set 5x minus 5 to 2 pi. So 5x could equal 5 plus 2 pi. And then we can divide by 5, which is 1 plus 2 pi over 5. So really, the division by 5 here is the shortcut. Taking 2 pi and dividing it by the multiplier. It's going to happen every time you set it to 2 pi, so you take the shortcut. All right. So what am I multiplying x by? 1/3. If I divide that into 2 pi, the period of this function is going to be 6 pi. So all I need to know is where to start. The sine function measures height, and if I don't do any walking around the circle, if I'm not moving my angles around, then there's no height. So I'll put a 0 in, and that's in the middle. Heights go up to 1, down to -1. So therefore, I've got in the middle and going up. So here a 0 gets me 9. I'll do this. That takes me back, and then I repeat the pattern, right? Hope you can see the repetition here. Okay, so let's put the 9 over on this side. And we're going up to what? 7 units, so 16, and down 7, 2. So that's my range, 2 to 16. And so 0 gets me 9, and 6 pi should bring me back to 9, which means you got all these nice symmetric places, 3 pi, 3 pi over 2, triple 3 pi, 9 pi over 2. You know, you can find a lot of numbers pretty easily. All right, we're trying to develop our rules of logarithms. For those who don't have the memorization sheet, I should post it sometime. Here are some very friendly approximations for e. E to the 1.6 is pretty close to 5. E to the 1.44, 1.13, 0.72, e to the 0 is 1. And knowing those, and e to the -0.7 is half, knowing that the minus sign reciprocates those amounts, allows us to look at the ln of 5/9 organically and by rules of logs. Rules of logs is quicker. So the rules of logs here is going to be the ln of 5 minus 2 ln of 3. That's what I see, which is 1.6 minus 2.2, which is -0.6. Now, let's see if we can see where the rules of logs come from by doing it organically. So ln is, what do I put on top of e to get 5/9? That's what we're after. And I know 5 is e to the 1.6, approximately. And 9 is 3 squared. And what is 3? E to the 1.1. Now, this is what you need to look at. That's what you need to look at to understand this line of work. So I hope you take a minute to look at it. Tomorrow, I'm probably going to do another one of these reps. And if you take the time to do these reps after 4 or 5 days, you should be getting some understanding. And hopefully in your classes, you continue to work with them. If you don't, I suggest you make a journal, write these out, and just flip through it. Only takes 2 minutes a day to look at this problem, remember it. That's what's going to put it in your long-term memory, some kind of activity like that. In our class, I just hand out a worksheet. Everybody goes to the board and does these problems. And we'll be doing that for the next 2 months, along with the other 50 or 60 problems from the first half of the term. So the final exam is going to be probably 100, 120 questions, and got to average at least no more than 1 minute per question in order to get it done. All right, so exponential growth. There's the asymptote, y equals 10. There's the shape. We're going to do a 3 to 1. There's a 3 to 1 ratio. That's what the base of exponential functions come from. I'm going to go up 5 to 15. If I pick the right number. And I'm going to go up 15 to 25. If I pick the right number. I can standardize this. What do you think the right number is? Hope you said 2. What's the next right number? Hope you said 9. Let's check these numbers. Let's put a 9 in. 9 minus 2, 7 divided by 7, 1. Oh, 3 times 5, yeah, that is 15. Yeah, I did go up 15. Yeah, and that was up 5. Let's put a 2 in. 2 minus 2 is 0. What's 3 to the 0? 1. Okay, so 1 jump of 5 on top of 10. And of course, you don't show those. But helps you understand exponential functions. Logs. Okay, so this log is going to have a 10 and a 15 in it. So you get the answer 10 here if I pick the right number. And I'm going to get 15 if I pick the right number. What are the numbers you say? I think I'm going to try a 2. Oh, yeah, be undefined. Log zeros. I don't care what the base is. This has got to be positive. There's a domain restriction here. It's got to be positive. So put a 2 in, it's not positive. So as soon as you put a number bigger than 2 in, yeah. And how much do you think you want to change that number 2 by? Oh, big clue, 7 units. Yeah, so I guess 9 is going to be very friendly. We'll check it in a minute. And of course, the next x is going to be 3 times that 7, which is 21 plus 2. So that's 23. I'm not really looking at this, but let's see if it works. Put a 23 in. 23 minus 2, 21. 21 divided by 7. Yeah, that's 3. Yeah, what's log base 3 of 3? Well, that's 1. 1 times 5 is 5 plus 10. Oh, it did work. How nice. Now let's put the other number in and see if it works. Well, let's put 9 in. 9 minus 2 is 7. What's 7 divided by 7? 1. What do you put on top of the 3 to get a 1? 0, you say. 0 times anything. 0 gets me an answer of 10. Okay, hopefully you got that. Get the science card a little closer to the next one here. I was kind of far away that time. Hope that came across all right. All right, very similar here. E 2.71, pretty darn close to 3. So we got something that's tripling somewhat. So I'm going to pick a number here. I'm going to pick 2 and 9. And I'm going to be making this one 3 times bigger than that one. So why don't we make this one go right there, and then 3 times that is about there. So if I put a 2 in, let's do it organically here. First off, we've got to say y equals 10, right? Still the same asymptote. Asymptotic behavior is over here. As I go to negative infinity, this graph is heading to an altitude of 10. All right, so I want to jump 5 again, so it's going to be 15 for the same reason over there. And then this one is going to be, if I pick the right number, 15 and 10, 25, still going to be 25. If I pick the right number, and it's not 9, because this is E. So I want this thing to equal 1.1. So excuse me, I jumped to the conclusion there without thinking. So 7.7, 9.7. Okay. And then you can do this every single time where this is a 3 to 1 ratio by creating those 2 numbers. You don't have to pick 3 to 1. We could have picked a 2 to 1. We could have set this thing to 0.7. Some students prefer that. I like working with the number 1.1. It's a little easier, I think. So let's see why it's a little easier. 9.7 minus 2. 7.7 divided by 7, 1.1. E to the 1.1 triples the 5, which makes it 15 units on top of 10, takes you to 25. All right, now there's tons of this practice on the YouTube channel. Rapid Fire 5, speed graphing e to the x and ln of x. So you can go look for that. I wish I had better organization with videos, but you know, I'm intellectually challenged around technology, just the way it has always been. So I can see 2 again. I recognize that so quickly because of the one before. ln function. If this is positive, then it's looking like that. If it was negative, it would be the inverse of decay. All right, I still am looking at a change of 7. So here I'm looking at x values, so I'm looking at 9. And I'm looking at the element 3, so element 3, so I gotta get 3 out of this, 7.927. That's what's coming out. Dyslexia. All right, so I gotta start this again. All right, so what do we have? We've got 10 and 15. If I pick the right numbers, I want to try to standardize this. What numbers am I going to pick? I'm going to pick, make this 1, so that was correct. 9 still gets me 10. ln of 1 is 0, 0 times n, get you that. And then we want 3, so 21 plus 2, 23. Twenty-three minus 2, 21, ln of 3. So hey, you got to be more careful, Jimbo. So ln of 3, 1.1, 5.5, 15.5. Yeah, I don't know why I'm pausing right now. For some reason, I feel like there was an easier way to do that. But anyway, that's that graph. Let's put 23 into C. 23 minus 2, 21 divided by 7, 3, ln of 3, 1.1 times 5, 5.5 plus 10, 15.5. And 9 minus 2 sevens get us a 1. ln of 1 is 0. So 9 gets us 10. All right. I already did this problem once before, so there's no reason to do it, except it's on the board, so we might as well. All right, so if you complete the square, then you're gonna get negative 10 is the x center, positive 5 is the y center, and so that's 125 minus 4 is 121. So radius of 11, you try it, complete the square, go for it. Oh, you know what I can show though? I can show, I think, x plus 10 squared over 11 plus y minus 5 squared over 11 equals 1. That's another way I could have written this. And so that's a little helpful when you get over to this side. Science card, come on. Getting old here. All right, very similar patterns here. All right, so what do we have? Horizontal diameter of 10 units, vertical diameter of 4. I don't think I can call it diameter to an oval, but I'm going up and down 4, down 4, up and down 4, side to side 5 and 5. And that's going to allow me to find some points. So if I make this -3 as an altitude, -3 on this side, -3 on this side, maybe you'll understand why this was one of your questions before we had actually started graphing these functions. I would say, hey, find 2 coordinates. Well, I'm going to find 2 coordinates now. So what makes this 25? 10. All right. And what makes this 25? -5. And if I held so the center, of course, is 5, -3. And if I go up 4 units, that should get me -1, down 4, -7, provided I pull the horizontal. Don't move horizontally. Okay, so you can check those numbers, they should work. Now, the more times you do this, hopefully what comes into focus is the ability to answer these questions on the spot. All right, cosine of 0. What's the cosine of 0? 1. 2 plus 3 is 5. Now you pause the video and try this. Cosine of pi, here's pi. What's the cosine, the width? What's the width? -1. -5 minus 9, -14. Sine of 0. What sine measure height? What's the height at 0? Height at 0 is 0. So +8. What's the height at pi? The other side. The height doesn't change, right? The height's 0. The heights go up to 1, down to -1 at pi. I'm in the middle, so it's 0. I get 20. What's the cosine of pi over 2? Straight up. What's cosine measure? Width. Well, what's the width right there? There is none. Cosine of pi over 2 is 0, so that gets you 7. How about 3 pi over 2? Straight down, no width. 7. Sine of pi over 2. Sine is height. What's the height of pi over 2? 1. 4 and 24. What's the height of 3 pi over 2? It's down here. -1. 3, 5, 8. Okay? You want to be able to do those fairly quickly and easily because it's going to help you understand this. The different ways to write it. So what are some different ways to write this? Well, we're looking for max. We're starting at a max. Well, there's two maxes. One of them happens cosine. That x is a max at 0 radius lengths. No walking around the circle. The sine function is a max at pi over 2. So why don't we write this using cosine and sine, and we'll see that they're 90 degrees apart. Right? I think that's 90 units of change. Okay, so what do we have here? We have midline. What's between 84 and 116, 92. We're going up and down 8. Let's do the cosine first. Cosine is a max at 0, right? So how do I make 2015 a 0? X minus 2015, that's done. And then we have what? The circumference of the circle. When we unwrap it, it becomes your x-axis. And what do you put on the x-axis? You convert years to radius. And what's the radius? Length change. Well, once around is 1 period. 1 period is 2 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And that's 2.5 revolutions. And that changed in 9 years, 2015 to 2024. So there you have it. Now we could have done it as a sine function because we're at a max. And where does the sine function max? Pi over 2. So 92 plus 8 sine 5 pi over 9 x minus 2015 plus pi over 2. There, that's a quick way to write one of those sinusoids. All right, so again, that's your workout for the day. You want to get better at a sport? You want to get better at your layups? Practice your layups. You want to get better at your foul shooting? Practice your foul shooting. You want to get better at trapping a ball out of the air? Better get to a wall. All right. We'll do another one tomorrow. I'm a big fan of repetition.